I'm Shungo, and I started baseball at a young age of 4. And it's provided me joy since I was a little leaguer to now at a math competition with my friends. But in all seriousness, for the past 12 years, I've taken more than I've given back. Baseball has provided me with tournaments I've been in, games I've played, and amazing coaches I've had, such as my current coaches over there. So, at the beginning of the semester, I thought it was finally time to give back to the community that served me for the past 12 years. So, what could I have done? Well, I could have coached young kids, I could have organized a tournament, or I could have made a video on how to pitch. But like many of my peers of my generation, and actually many of you in this room, I enjoy STEM, and specifically I wanted to touch on engineering. So combining my two interests in engineering and baseball together, I decided to make a pitching machine. So my initial driving question was such. I really wanted to hone in on the idea of the pitching machine being portable, unlike industrial pitching machines which you can't really carry around, and the idea that one can practice by themselves, so you don't actually need a second person feeding the machine or throwing at you. So here's my my project proposal where I go through my rundown of my idea, and here's my management plan where I set deadlines for myself so that I am kept in check. And finding a mentor was a bit tough, but after a month of searching, my dad was able to connect me with one of his friends from college. He has a PhD in engineering, and one of his students approved of the mentorship. And his name is Xiao Xinta. Sorry if I brutally mispronounced that, but since he lived in Japan, he wasn't able to provide me with physical help, but he was able to provide me with some advice, which I'll talk about later. And the last substantial networking that I did was talking to Mr. Harvey over there, who is in charge of the makerspace and the robotics lab, and he offered to help me throughout my project. So my building phase started off with prototyping. So the first thing I did was take a scan through the robotics room, and I picked out a pair of motors and wheels, and with these specs, it would hypothetically throw at 50 miles per hour. And mounting the wheel was a bit of a pain, since this part that was supposed to connect the wheel onto the motor didn't actually exist in the robotics lab. So we had to handcraft that, and for that I had to go to the middle school makerspace to get Mr. McMullen's help, who helped me smooth out this slab of metal, which was used using a lathe. And then we just drilled holes in so that the screws and the rotor of the motor would fit in. And eventually, after clamping that onto a piece of wood, it looked like this. So this was a prototype. So the first prototype looked like that. It was basically just two wheels mounted next to each other with a pipe in between to funnel the ball. It was relatively portable at this point, so I was hopeful for it, but let's see how this goes. So pathetically, that did not work out at all, and we had to kind of change how we were going to design it. So I had two options. One was to get stronger motors. The other was to get wheels with bigger radii so that the tangential velocity would be higher. I went with the cheaper alternative, which were the wheels with the bigger radii. So we got bicycle wheels, which were 14-inch in diameter. And the good thing about those bicycle wheels as well was that they had rubber tires, which are a lot more grippy than plastic wheels. So theoretically, it should grip the ball better than a plastic wheel would. So the second prototype was basically just the first one, except the plastic wheels were replaced with rubber bicycle wheels. At this point, it was kind of getting not too portable, so I wasn't too happy about that, but here was the results. So that was an improvement, but it still wasn't quite there. It didn't even go to a batter's waist height, which would be probably like the average strike zone. So we still had a bit of refining to do. And at this point, I kind of doubted if I could actually make this machine portable, if I should just stick with a really heavy, big industrial pitching machine. And this is when my mentor stepped in and told me that I should decrease the distance between the wheels so that they would come in contact with the ball for longer, and that I should angle the wheel so that it takes advantage of the Magnus effect. And the Magnus effect is basically just disruption of airflow. So as you can see here, the arrows are pointed in a parallel, are flowing towards the ball in a parallel direction. But since the ball is spinning this way, the air is being hooked upwards and back towards the ball, which then causes the air to point downwards. And as you can see, this means that the ball is actually exerting downward force onto air. And for those of you who are taking physics, following Newton's third law, the air applies opposite and equal force, which is upwards. So this allows the ball to stay up in the air, and which is why when you throw a baseball and it has backspin, it doesn't just immediately drop. So the third prototype is basically just the second, except the wheels were closer together and the wheels were angled. And this result was, well, you'll see for yourself. Whoa! That's the reaction you actually have. Yeah, so clearly that worked a lot better than the second or the first and second prototype. And I decided that I would end up with this design for my final product. So now that prototyping was out of the way, it was time to wire. I'll kind of explain this briefly as it kind of gets a bit technical and complicated, but basically this was a diagram for how I wired, and when you do apply this to the actual wiring, it looks like this. Just a lot more complicated. You probably won't understand. That's fine. The one thing that helped me a lot throughout with the wiring is this thing called a MOSFET. Basically, what this does, I won't get too detailed, but it's basically it looks like this, and it has 3 pins. This is the motor controller that I connected the motor on the top to. These 3 wires down here act similarly as the 3 pins I'll just explain with the MOSFET. But basically what it does is just like any other wire, it takes in current from the source pin, which is the far right, and the current exits from the middle pin, which is called the drain pin. But the thing that makes this MOSFET so special is that you can actually code it so that it would output less voltage or more voltage depending on how you wanted to code it. So that was inputted through the source pin, or sorry, so through the gate pin. And this way you can control how much current goes through the MOSFET. And this way you can control how fast the motor is. You can control I have LED lights here, but you can control the brightness of the LED lights using this way. So this was really useful for my wiring, as I needed to make some adjustments with the speed of the motor, the brightness of the lights, and whatnot. And this is what the LED ended up looking like. And we needed a timer mechanism so that after you hit a baseball, you wouldn't see another one coming at you in the next 2 seconds, or a lot more, 10 seconds. So basically what I did was get a gearbox, which is basically a series of gears that allow the rotor, which is the tip of the motor, to spin a lot slower. So as you can see here, this is what a gearbox is. The gears are basically just like compacted into this box. And this allows the rotor to spin a lot slower to a certain ratio. And I had mine to be around 8 revolutions per minute. So, and attaching the plastic bowl on the rotor, this is what the timer mechanism looked like. So as you can see here, the timer mechanism works so that it feeds the ball into the machine every couple of seconds instead of having no timer at all or no box at all. And so then my final product basically looked like this. It is just everything that I just talked about combined into one machine. The prototyping, the wheels that I prototyped is in the box. The LED lights are just strapped across the side. The timer mechanism is on the top. And the wiring is also inside the box. And actually, a quite clever idea that Mr. Harvey suggested was to put a sheet of acrylic over it so that people can see the prototype and the wiring, which looks cool, and it's not just like any wooden box. So here's probably the most entertaining part of this presentation. You guys can see this machine in action, and us baseball players sort of trying to experiment with it, so I'll be the first one to embarrass myself. Oh my god! And here's Paul knocking me right after. But in all seriousness, I kind of want to showcase what the ball machine does. So, sorry Paul, I used it as an example, but as you can see here, the lights weren't working due to the poor connection, the wires were a bit off. But as you can see, I'm not actually touching the machine right now. I'm just next to it so that if Paul hypothetically hits it straight back at the machine, it wouldn't like break. But as you can see, the timer mechanism is working in this case. And and the next is just waiting for set. So one thing I wanted to fix in this project was just improving the motor's accuracy. And to do that, I think I just needed a better connection between the motor and the wheel. Because for now, as I told you guys earlier, it is just a handmade piece that connects the motor onto the wheel. So if we actually get the actual piece and it's a lot more stable, it would have better accuracy. And for those of you who thought Sophie couldn't hit from this side, here's like going so straight hard enough that Paul gets knocked down. And for courtesy's sake, I just want to include Kim and Jun, who actually came out and helped early finish as well. Alright, so this day was a lot of fun. And my future plan with this project is to add this thing. The first thing I can think of is to add this thing called a potentiometer or a variable resistor. What this does is, it's kind of like a MOSFET, so it allows, you can regulate the current that goes through, you can control it to be lower, higher, whatever. But the good thing about this is that unlike a MOSFET, you don't need code to change your current. Basically, it's just a knob that you can turn to adjust it. So if you're out on a baseball field, you wouldn't need to bring your computer to change the speed of the motors. If I connect this to the motors, you can, obviously, theoretically, you can change the speed of the motors to make the balls come out slower. You can change one wheel to spin faster than the other so that it accelerates one side of the ball faster than the other, which allows for breaking balls to be thrown. So what breaking balls are in baseball are pitches that curve with the same Magnus effect. In this situation here, you can see this wheel spins a bit faster than this one, so the left side of the ball gets accelerated faster, and then it has this spin, which makes it curve that way.
130キロのキレのあるシュート。
So basically, with a variable resistor, I'd be able to control the speed of the two motors, which allows me to use this technique. And what I learned from this is that obviously it was my first engineering experience, and obviously when you see the first prototype, it clearly didn't work out. I learned that it took a lot of trial and error to be able to come up with a functional prototype. And also, as you can see here, the pieces I used to build this thing, it's a piece of wood, plastic pipes, PVC pipes. These are actually used for your drains in your bathrooms. A plastic box from Daiso, and a piece of wood that's like surrounding it, and LED lights. And probably the most fancy thing you can see here is like the 14-inch bicycle wheels. So obviously it worked. The materials I used were a lot of scrap material, and they're clearly not meant to build a machine. But in the end, I was able to do it, and that really helps me foster my creativity. And I really want to give thanks to Mr. Harvey, Sophie, Paul, and Jonah here. Mr. Harvey helped me out for the entire 3 months of building. I would come in every single catalyst block and every free block, and he would help me out, even though I might be like kind of incompetent with him sometimes. So he helps me with as the captain of the robotics team this year. He helps me with locating everything in the robotics lab. He helps me with the wiring and whatnot. And Paul one weekend came over to help me finalize my ideas for wiring because I was kind of confused with them. Because he did an engineering project last year as well. And he also gave me ideas that I didn't actually end up using in the final product. But I did find it to be really useful input, so then I want to thank that. Jonah compiled all the footage into a video for me for my website, which I'll present later, so you guys can take a look at that too. And also, one thing that I learned about Mr. Harvey, aside from the fact that he's a great builder, is that he's also really good at baseball. So here are some videos of Mr. Harvey hitting. He's throwing a low pitch, of course. Throwing a high heat. And actually, this is really fun. And he was the only one who actually did not swing and miss a single time this day. So, so thank you. This is my website where you can see a lot more of the detailed explanation as to how this really came into place. So yeah, thank you. can tell you what was my least favorite part. That was prototyping, because I didn't really think, because after the first and second times, they both took a couple of weeks well, maybe like a week and a half to finish. And it really made me kind of, question if I could really do this in a 4-month period that I was given. Okay, going back to your question, my favorite part of this build itself was actually probably bringing my friends down to the baseball field and testing it out with them, because I was able to celebrate my final product with everyone else. Yes, Scarlett.
I know that you said you wanted to make like a smaller machine. So if you were to continue this project, what steps do you think you'd take to make these smaller, more affordable machine?
One thing that I've observed that kind of didn't work with the design was that when you feed the ball into the machine, oh shit, I was going to bring a baseball, but anyway, the ball ended up to have black smears all over it, which I assume to be are the tubes and the bicycle wheels. So clearly they're not actually spinning as fast as I want them to spin. It is, obviously if you, when you skid on a bicycle, it leaves bicycle marks on the ground, right? And it's the same concept. It's basically sliding on the ball, and it's not gripping as fast as it should be. When I look at industrial pitching machines, I do observe a lot of them having actually non-grippy wheels. So they use metal wheels that actually fit exactly the size of a baseball. So if I am to implement that concept into the building, if it works, then I can obviously kind of scale down the machine and make it more portable. Yes.
Just one question. Why was my pet foot not featured? But okay, in all seriousness, I just had a question about the limits of your launcher, because it only has one angle, and so in the future, how would you try to change it so that people can adjust it to their own height?
For now, the only way to actually adjust height is to increase or decrease the distance between you and the machine. So I mean that, but in the future, when I was going through the rundown of my idea initially, I was planning to add a computerized system, so it was connected to something like this, remote. So by doing so, maybe if a coach or a second person is there, they can control it so that it's kind of randomized for the player to hit. Maybe I could just code a computer system into the Arduino, which is actually the as you know, it's a microcontroller that controls everything, so that the wheels do spin at random rates. So yeah, using the variable resistor that I mentioned earlier and randomizing it using whether it be a coach controlling it or the Arduino, which is a mini computer kind of thing controlling it, I think that's going to be able to make the pitches kind of randomized and more practical for the future. Yes?
I just wondered what you learned about working collaboratively.
So a lot of my, I hadn't really reached, like a lot of people in who are taking Cal this semester, I haven't really reached out to people I didn't know in the past. And obviously, I had only taken robotics in freshman year, and so then I didn't really know Mr. Harvey, but I was, after reaching out with him, he was the one who helped me by my side, and he helps me construct this by instructing me and actually sometimes helping out physically. So obviously, I did collaborate with Mr. Harvey, but aside from that, I invited my peers to give me feedback and input, whether it be Sohit, Paul, and see how I can improve the engineering aspect of this. So, and obviously my mentor was involved in this as well, with their email and stuff. Any questions? Yes?
What are you gonna name the machine?
Am I meant to joke here or am I meant to actually give a serious
Give one.
Well, should I just tell you your brilliant idea? The day I brought this up, my coach was actually on the field, and he I don't know if he planned it or not, but he told me on the spot to name this the Shungo Najima machine. But for now, I kind of don't know what to do with the naming. I guess for like advertisement purposes, I could stick one of those like SAS stickers on like the feeding map, as Mr. Harvey said in the past as well. But yeah, so I don't really have a company for it. So.